Hey there, Ty. Figured since we're not able to meet up, we'll try something a little different, see about making a video, because I want you to be able to keep making some progress on this robot program that we're making and processing, all right? So let's see here. I want to show you what we have left to do. And I'll go over to our current program. Oh, make sure that you can get GitHub to work on your computer. So I'm going to make some edits here to this robot file. I'm going to try to post that up to GitHub. I'm kind of learning it myself, but then you should have access to the stuff that I do right here in this video. That's pretty cool. That's technology. All right, so this is what we had last time. We had our little robot that we could make drive around in a circle. So what's left? We can make this guy drive around. Well, the next thing we need to have a basic robot is we need this guy to be able to take some measurements. I think it's going to be pretty cool. I actually haven't done this before, so I'm just doing it right now, and we'll see how far I get. Here's what we want to do. So we got, first I got to get my pen going here. So we've got this little robot arena that we're driving around in here. I'll just sketch it out. All right, those are the walls, those are the edge of my sketch. And we've got our robot. We can tell which way he's facing by that little sensor on the front. Now what we want to do is we want to make that a real live sensor. We want to be able to send a little beam of light, if you will, out of that and keep track of where that little sensor particle of light goes and see when it hits one of the walls of this program. And we want to print out, I'm going to print out the number of pixels, and then what I want you to do is I want you to make this all work nice and have it tell us the distance in meters. But let's say that, what do we got here? Maybe we'll make each of these grid marks 100 pixels. I think that works out actually pretty perfect. What size was this screen over here? Yeah, it was like 500 tall. That works perfect. So we got 5 grid marks here. Those are each going to be 100 pixels. So just eyeballing it, maybe this is 250 pixels right now away from the wall. And if it was over here instead, pointing out in this direction, maybe that looks like that's 500. So we're gonna have a little piece of text appear above this robot that tells us how far it is from the wall. Make sense? Kind of simulating one of these little laser sensors. All right, so that's the dream. We want to simulate that laser sensor. How we're going to do it is I'm going to create a little object in processing for this laser, and what it's going to do is it's going to move out along a straight line until it hits a wall, and it's going to keep track of how far it travels over that time. All right, so let's see if we can make that happen in processing. I'm going to come over here. I'm going to get processing going. So I think we want to do this in our robot class, and I'm going to show you something else. This will be interesting too. Hopefully this won't break GitHub. I think we've done this before, but we're going to make a new tab in processing where we're going to start keeping some of these classes. So what I did there is I clicked that little down arrow, and I just clicked new tab, and I called it robot. And I'm going to take all the stuff we have now in our robot class. I'm going to take it out of our main robot sim code, and I'm going to put it over here. Oh, another thing, so write this on your homework list. We got to start getting some more comments going in this code here. That'll be good. But here's what we want to do. So we've got this void update. We want to put a new method in that will let me take a measurement. Void measure. Like that. And here's how this class is going to work. I'm going to start with some variables here. I'm going to have float, X and Y. Oh, actually, is this going to work? I don't think that's going to work because I don't want to overlap the name X and Y. So I'll call it XM for the measurement X location. And remember, what we're going to do is we're going to imagine this as like a little particle of laser light that gets shot out of the front of the robot and hits the wall. I'm not going to worry about making it come out of the front of the robot for now. Maybe I'll leave that as a homework assignment for you too. I'm just going to make it come out of the middle of the robot. And that'll be close enough for today. XM, so that's going to be and actually, I'm just going to set that equal. I'm going to start it out at the X location of the robot. That's going to be X location of laser. All right. Float YM. Maybe we should call it XL and YL for X laser and Y laser. But the laser business, that's all made up, right? Obviously, it's not a real laser. It's just something in our code. So we're just taking a measurement. Y location of let's maybe make this comment better. Of measurement particle. Let's call it that. I don't know. Maybe that's confusing, but that's what it is. It's like this little particle we're shooting out at the wall. Seeing how long it takes to get there. So how are we going to do this? Well, we need to give this particle some velocity. Float V VM for the measurement velocity. And I'm going to set this equal to 1 because I think that's just going to work the best. So this thing's going to move at a rate of 1 pixel per update that I do of this measurement thing. But when I call void measurement, I want it to send that pixel out the whole way until it hits the wall. All right, so let's see what we can do here. We need to get the angle, but we have this theta, which is the angle of the robot, so that should work out all right. So let's do this. So we're going to say while, what conditions do we want to check here? We want to check in this while loop to see if it's hit this wall or any of the walls on here, right? So how can we check if it's hit the walls? We could say things like while xm is less than width, right? And we want to make sure that xm is greater than 0. And we want to make sure that the measurement in the y is less than the height of the screen. And we want to make sure that the measurement y is also greater than 0. So while all those things are true, we're going to keep updating the position of this little measurement particle. And what we're going to do is we're going to add to the x position the VM there, so the velocity times the cosine of the angle theta. All right, so picture this. We have the initial x position is going to be, we'll do plus equals. So we'll add to this initial x position the velocity times cosine of theta in the x. I think you've seen that guy a lot. And in the y direction, we will add that times the sine of theta. So if that doesn't make sense, pause the video, make a little sketch of something like this on your paper, and convince yourself that that's what we should do to make this particle kind of travel along this line going out to the wall. So we're going to do that while it's still inside the boundaries of the sketch that we have. And what I think we'll keep track of here is we need to keep track of how many times this code is run to see how far it's gone. Float. These don't totally have to be floats, but we've never worried a lot about that before, so we won't worry about it now. And we'll say dist, which is going to start at 0. And every time we go through this while loop, we're going to say dist plus plus. So that should give me the number of pixels that I have. Okay, I'm not 100% positive this will work yet, but I think it's going to work. And so what I think I want to do actually is instead of making this a void, let's make this a float, because we can get a number back from these methods. And let's get back, let's return the dist that we got there. All right, so what this code should do, and I haven't run this yet, so I don't know if it will, is it should shoot out that little particle and see how many times does it have to go through that while loop until it hits that wall over there. Let's just see if we're lucky. Let's see if it works. So I'm going to come over here, and we want to put some text, and I'm going to put the text. So we'll do text, and where are we going to put this text? We're going to put it at the r.x location, right? That seems good. You know what actually I'm going to do? We can do this a couple different ways. Maybe you should experiment with those. But I'm going to put it in my update class here. So after I translate to the robot location down here, I think I'm just going to call this, this function that I have here. And so I'm going to say text. And since we're already at the robot location in the X, we'll put it there and we'll move it up by, let's say, 70 pixels. And we got to say what text do we want to put in there. We're going to put the measurement that we get here. So I'm going to say measure. I'm going to call that function. And that's going to be the text that it'll print. Should be that measurement that we get. And I think, I'm changing my mind here. I think I'm going to make this an integer just because we don't need a lot of decimal places in there. So we'll return the int of the distance that we get. That could be enough. I don't know. Let's just see what this does at this point. It may not do anything. All right, we got a number. It's kind of interesting. Doesn't seem right to me because it seems like it's more than 300 pixels and the number is going up there. Now, that's really strange. Let's think about what it's doing there. Let's drive over by this wall because that number should get smaller as we get closer to the wall. It's kind of doing it there. But yeah, and there we just got like some huge number. Weird, but we're getting a number, so that's the good news. Let's think about this for a second. And I think I'm going to pause this while I think. All right, so I'm back here. I think one thing I want to do is I want to draw the line of that little laser light that we have up there. And in order to draw it, I don't want to, I'm going to take this little measure text out here. So here's what I'm going to do. Outside of where I do all those push and pop matrices, because those can make things confusing, I'm going to take a measurement up here, and I'm going to say float dist equals, get my measure outside of there. And then in here, where I have my text, I'm just going to put the dist that I measured there. All right, so why am I doing that? Because up here now, what I'm going to do is, as I'm sending out this laser light, I'm going to, let's set the stroke here to be red. So it's RGB 255.0,0. And I'm going to draw just a very small ellipse at xm, comma, ym, comma, real small. We'll do 2, 2, see what that looks like. So this should put a bunch of dots at the locations where it's putting these xm's and yms. Okay, weird. I think we still got a bit of a problem going with the theta angle of our robot here, because it's shooting the laser out the side of the robot. But if you look at it, that's promising, because that I buy is the distance out the side of the robot. All right, well, that's good troubleshooting there. So a better way to do this would be to actually think about it, but the way I'm going to do it is to do theta plus pi over 2. It's just pi over 2. Let's just add some little angle there. And we've got to put this on your homework list too. We got to fix up those angles. Okay, there we go. So let's see if this is working, man. It looks like it's working. Oh, yeah, look at that distance. So you see how the distance is going down as we approach the wall, and then it's going over there. Oh, yeah, that's beautiful. That's what we want. Nice. Wow, I can't believe we got that to work like that. All right, cool. So we got that going. Make sure that part makes sense to you at first. And then what I want to show you is one other thing that I'm going to do here. And this part I'm not 100% positive is going to work either, but we're eventually going to need to get to the point where, going back to my little sketch over here, we're eventually going to need to get to the point where we can start adding some objects into our little environment, because it'll just be boring to have this guy drive around in a box. All right, so we want to have, be able to put a little wall into this environment. And to do that, we'll need to have a map. And to have a map, I think the easiest way to do that in processing is going to be to use images. Processing has what are called P images. I think stands for processing image, something like that. So I'm going to create an image called map right there. And we've got to, when we create an image, you can look up some details on map in the reference as usual. Or, I'm sorry, about the P images in the reference. But first thing we got to do is we got to create it. So I've got to say create image. I think that's a thing here. Yeah. So I'm going to create an image for, oh, and I got to say the map. I'm kind of remembering this as I type. The map is going to be create an image. And we got to give it the width, which will make the width of our screen. The height, which we'll make right there. And this last thing we have to give it, I think we tell it, is this black and white? Is it RGB? So I think I can go BW maybe, gray scale. Let's go with gray. I don't know, maybe I should look up that up in the reference. Let's take a look here. It's not gonna hurt us to check this out. And that way you'll know where to go to get some extra information. Find P image here. And actually we'll go with the create image class that we got there. All right, so what are our options here? So either RGB, ARGB, alpha, okay? So I guess there isn't one that's just grayscale, and that's fine. That's honestly doesn't make any difference to us. So we'll make this RGB colors there. So that's our map, and here's what I want to do. I want to be able to, well actually I need to be able to show the map. So instead of doing the background, what I can do is, actually let's just see what happens now. What's in there if I do image map, and Map kind of works like a rectangle. You give it the upper corner, so we'll make it the upper side of the screen. So I'll get rid of that background and do that, and put a semicolon there. And we'll just see what this looks like. I think it'll just start out as a white image. Okay, interesting. It starts out as a fully black image. So in order to set the individual colors of every pixel, we need to get a little bit comfortable working with the pixels in this image. So int I equals, so and to the pixels, I think you know that just like the pixels on the screen, you got a width and a height. So I'm going to say for int x equals 0, x less than the width, x plus plus. So we're going to need 2 for loops to do this. For int y equals 0, and y is going to be less than the height, y plus plus. Well, this will be good. This will allow me to show you a little bit about working with these images too. So let's make the map pure white. We're going to say map, or no, we don't want to do that map command. That's a different thing. What we want to say is map.set is the command to set the pixel color, and we want to set the pixel at an x and y location to be white. So I think we can do, if we do this, I forget if this works or not. If that'll set every pixel to white. Okay, it didn't, it set them to some other color, so I think we want to say color 255, see what that does for us. There we go. So now we got a pure white image for our map there. But that's not what we want. We want to be able to put some obstacles onto that map. So I'm going to come down here and I'm going to work with the mouse press. Mouse pressed, like we had before. And I'm going to say, so if the mouse is pressed, I'm going to do the same thing. I'm going to set the color of a part of the map, but instead, I'm going to set that color to be black. So I'm going to set that equal to 0. So now this should let me draw in some walls here. I didn't like that at all. Why didn't I like that? Because those are, okay. We don't want x and y. We want to set the mouse location, mouse x and mouse y equal to black. So let's see. Can you let me do that? Oh, you know what? Actually, you probably can't even see it. There's these very small little black dots on there. So this is where it'll get to be a little bit interesting to figure out how to draw more than just those little dots. It's not as easy as drawing like ellipses. You always have to work with the pixels, but I think we can do this. I think if we were to think about x is equal to, let's say, mouse x, and x is less than mouse x plus, let's say, 20. So I want to draw a little square to be black in there. So I'm going to say mouse y, and we will say y is less than mouse y plus 20. We're going to set that color equal to 0. That should work. Let's just see what happens. Let's see if I can kind of paint some little squares black now. Oh, nice. All right. There we go. So now we got some, at least little ability there to put some objects onto our map. It was very like primitive at this point. What I would like though is I would like my laser when it's looking at that object there to see that there's something there. Right now it just sees the wall. So how can I do that? Well, I can come back over to my, my map here and say, while this whole thing says we're inside of the map, or we're inside of the outside edges of the screen, and I also want to look at my map, and I want to say, and my, what do I want to say, map.get, now I can use that to get the location of the, to get the color of the pixel at xm, ym. So while map.get, now I think what I'm going to need to do is I think I'm going to have to do one more thing. So to get the, whether it's white or black, I think I'm going to have to do brightness of map.get there. So while that brightness is equal to 255, I think that will say that the map is white there. So let's just see. I didn't like that. The method get is not, oh, okay, because it doesn't like those being floats. So just make those ints. Int xm, int ym, let's run that. All right, so let's see here. So now this guy's driving around doing the same thing as before. So that's all encouraging. So let's get him going this way for a little bit. And then I'm gonna put some obstacles over here. Let's see if we can see any of those. Ah, look at that. He saw those walls there. Did you see that how the number went down? Let's do it again. So I'm going to drive him on over there. So he's got 500, 400, 300 pixels away. And again, I want you to make those all meters. And we'll swing around so we can see that far wall. Oh, look at that. It's 300, 200. And then he sees past it. Ah, this is cool, man. Do you see this? Are you getting the feeling of how this is going to do what we want it to do? Awesome. So now we can put these little objects into our map. And again, obviously, this is all very primitive. But try back in there. All right, and we are going to eventually be able to get all kinds of stuff happening. Oh, that's cool, man. That is really cool right there. I can't believe that worked as well as it did. All right, so you're off to the races. You got everything you need here now. So I'm going to call it a day with this video. I'm going to push this out to GitHub. Like GitHub is a little confusing to use, but I think it'll be good for you to try to get that working, and this is going to be the easy way for us to share all these documents. So I'm going to push all these changes I made to GitHub. If that doesn't work, this video kind of showed you what to change in your files, but I think that'll be good. So best of luck. I want you to keep working on this, man, right? You know, set some time aside to do these things. What you can do is eventually we'll be able to say things like put some if statements in and say, if, say the distance to one of these walls here. So if the distance to, you know, a wall over here, the edge of the screen or one of those things is less than 100, turn 90 degrees or something like that. Or make one of the motors move faster. So that'll all be good stuff for us to think about. Oh, actually, one more thing before I sign off here that I want to show you about. Once you get that map, every time I run it, I'm starting over with a blank map. What I can do is this. I can say something to that if mouse is pressed. I don't know if I want to save this every time through because it takes some time to save the file. So I think there's something you can do that when you close the close processing, you can run like a little bit of code before it closes. Let's see what that's about. Maybe it's called like close or something like that, or like on exit. All right, we'll look that up. There's something you can do that runs like when you exit the code. I think you can get a little piece of code like that. So for right now, I'll just do it whenever I do mouse pressed. I'm going to save my map. So I'm going to say map dot, and it's just this easy, map dot save. And I got to give it a name. So I'm going to save it as map.png. That'll be easy enough. And here's what I can do up here is rather than setting it initially like this, from now on, actually, I guess I'll have to run this first, and then I'll press the mouse so that I can get a save thing. And you can see how now, yeah, every time I press the mouse, it's going to run a little bit slowly. So this is not like world's greatest way of doing this, but that kind of works. All right, so there's my map. And now if I exit out of that and I do Control K, I can come over here and I can see the map that I created last time, and you see my little blocks there. And so now instead of doing this, instead of creating this image anew every time, I'm going to just load the image map.png, put that in quotes. And so now I should get those little blocks that I drew last time in there, so we won't have to draw a new map every time, which is going to be awesome. Oh yeah, look at that. That's nice there, man. That's real nice. Look at that. Cool. All right, so that's going to be the thing. And like I said, if we add a few extra things in there, this is not the best way to do kind of saving that map. It'd be nice to just save it when we exit. But we drew those new pieces in, and now they should also appear when I restart. All right. Cool. All right, you got it. So keep up with the GitHub, experiment with this, and we're getting like a really good representation of a robot going here. So you got some stuff to be working on. Let me know if you got any questions. Take care, and hopefully, I think next weekend we should be good to meet. So, all right, talk to you later.